I am here with Durga Malladi. Durga is Senior Vice President and General Manager of Technology Planning, Edge Solutions, and Data Center at Qualcomm. And we're here to talk about some new products that the company is announcing. Durga, let's jump right in and have you introduce the new products to us.
All right. Thanks for having me. So, we are announcing two solutions for AI inferencing in data center. These are two generations of products, the AI200 and AI250 family of products. The first one, AI200, it's a rack level solution that scales down all the way from rack to cards to servers. And this rack level solution, it's direct liquid cooled. It's based upon our Hexagon NPU family of inference processors that we have used extensively, but it's a highly scaled up architecture. It's an architecture that allows us to go all the way into the rack level part. When you take a look at the benefits of this inferencing solution, we feel like it has one of the best industry leading TCOs, both in terms of the raw performance and performance per watt, and the cost that's associated with it. And we are sampling this starting from 2026 onwards. So this is the first generation. It's the AI200. The AI250, we are announcing that concurrently, is going to be sampling in 2027, but it has a few more attributes that actually come in. The first one is we bring in a very different kind of a memory architecture into the data center domain. It's based upon near memory computing, so it's an innovative memory architecture. Effectively, what it does is it increases the effective memory bandwidth significantly, greater than an order of magnitude. And what that does is allows for like a much better TCO and even better KPIs in terms of tokens per second and so on. A second element that comes in with this is it allows for existing anyone who has an existing solution as well to mix and match with our solution and theirs to provide a disaggregated AI inference. So it's a highly flexible solution in that sense. So that's the gist of our AI 200 and 250 family of products. 200 sampling in 26 and the AI 250 sampling in 2027.
Let's talk a little bit about who you see the target
Mm.
user for these.
So our customer base is a combination of both the tier one hyperscalers and a lot of the tier one CSPs around the world. Just a couple of points to be made in that. In our earnings call back in September, Cristiano had mentioned, he had alluded to one of the design wins that we have in this space. And prior to that, back in May, when we were in the Middle East, we signed an agreement with Humane in terms of the deployment that's coming out. Stay tuned a little bit on that front over the next quarter as we reveal more details in terms of the customers.
I was at the launch of the AI 100 back in 2019. So this is not Qualcomm's first entrance into the data center and CSP market. Talk a little bit about the lessons that you've learned since that time.
That's an excellent question. So AI 100, you're absolutely right, was announced in 2019, which, by the way, if you kind of think about it, was 3 years before we all started using the phrase chat GPT. So kind of think about it that
Certainly
way.
a different market and a different
It
world.
was a very different age back then. Transformers were fairly new, and a lot of the workloads were actually based upon computer vision. But it actually hit a sweet spot with like it's an accelerator card. You can use an existing COTS server and use it for any of the edge processing that you can do, and not in the devices, but as an edge appliance, if you will. So one thing to actually understand is that in the meantime, between then and now, there's a lot of places where we built our strength and we proved ourselves in a gradual and systematic manner. We started doing a significant amount of generative AI inference in devices, starting from smartphones, then into PCs, and into automotive. And we've kind of not just proven ourselves, but also learned a lot of the lessons which we baked in terms of scaling up the architecture. If you can scale up from, say, a doorbell to an automotive, then actually that's like a massive generational leap. Then this is like the next leap from there onward. So we feel extremely confident about our solutions in data center at this point.
Talk a little bit about the continuity across those different types of devices. Are we using the same or different CPU and NPU architectures for the cloud AI devices?
Inside Qualcomm, we have what we call as a roadmap that is based upon a single technology. So, in terms of, let's say, the NPU processing, which is designed from ground up for generative AI workloads, that's a basic unit of the processor itself. It doesn't mean that we use exactly the same flavor in every single business line. It's customized and modified just a little bit to make sure that we can actually cater towards that business. So, when it comes to data center, the most important thing is not to have like a single or two NSPs that are put together, but thousands of these as they are put together. And that's a place where we did a lot of the investments. It's a scaled up architecture that we focused on. The other subtle distinction is that the workloads in data center and the workloads in the devices are slightly different. A lot of the workloads in the data center actually are just run natively in floating point arithmetic. While on devices, we actually tend to quantize and use integer arithmetic. So there's some subtle distinction over there. But by and large, there's extensive reuse. Like there's a bedrock of software that is common across both platforms. But then we have a lot more capabilities that we have added in our data center solution.
We've talked a little bit about the evolution of the market over the past several years, and that's brought a lot of competition to the AI inference space. Certainly, in the enterprise and with CSPs, we see NVIDIA, the large CSPs have their own custom silicon offerings. What do you see as Qualcomm's edge in this space?
A couple of points over there. So, in terms of we have both the CPU offerings and AI offerings in the data center. And of course, the product announcements are focused on AI 200 and 250, which is on inference. But we have our CPU offering into the data center as well, which addresses both general purpose compute and AI head node workloads. One thing that we have done, as we've discussed with all the prospective customers, is they have their internal solutions as well. And we have been flexible in terms of saying, look, this is a solution that can actually mix and match and complement what you might have. One of the parts that actually, if you just focus on the inference aspects, is let's take AI 250, for instance. Given the fact that our memory architecture provides a lot of benefits on the decode section of AI inference, there is an opportunity for everyone to actually embrace an aspect where the encode prefill is still done with their processors and decode can be done on our processors. Conversely, back in May of this year, when we were part of an NVLink announcement that was made by NVIDIA, we said, it's an ability for our CPUs to coexist with someone else's GPUs inside the same rack. So what we have brought to the table over here, as we work with hyperscalers and all the other tier one CSPs and beyond, is flexibility. We provide our solutions, but it's not like a monolithic architecture. It's not like one size that can be used for everyone. It's not all or nothing, but you can cherry pick specific components from our products and then make them work.
Let's dig a little bit more deeply into the memory architecture. Memory bandwidth is a key limitation for AI inference, and it sounds like you're doing some interesting things there. Elaborate on that, please.
Yes. Historically, if you just take a look at the memory architecture and think about the two extreme views, one is when you start going into devices, it's all based upon LPDDR, where the power consumption is very low, but the memory bandwidth happens to be very low. It kind of fits the needs for devices very well, but it's not ideal if you just go with that sort of a memory bandwidth. Conversely, on the other extreme, we have typically the likes of HBM, which is used quite extensively in data centers, very high memory bandwidth, but the power consumption is not in the same league. What you want really is an ideal mix of both, a very high memory bandwidth and at a very low power consumption. The near memory computing architecture that we are bringing in with that's the innovative memory architecture that we are talking of. It allows us to bring in the best of both worlds, very low power consumption, but at the same time a step increase in the memory bandwidth, and we are projecting a greater than 10x increase in the memory bandwidth. That actually changes the game quite a bit because, on one hand, first of all, it solves the decode portion of the problem very well in an effective manner. But the second part is that the power consumption is still low. So when you kind of put together the overall TCO, there's like a higher order benefits that come in because of the TCO aspects as well. So near memory compute is not fundamentally new. I mean, it's been there in academia and research for a period of time. But we believe that our investments in this space have actually they are beginning to show up, and we decided to then bring this in into the data center domain.
And is the near memory aspect of this, the kind of co-location of compute memory, at what scale is it happening? Is it happening at the chip scale, server scale, rack scale?
This happens all the way down into the chip scale over there as logic gets introduced right next to memory, and then it starts scaling up from there onwards. So think about it that way.
And how does that translate into inference performance metrics?
The inference metrics, because of the fact that the when you start putting together both the encode and decode at this point, it doesn't change KPIs like time to first token, because that's kind of dominated by the first part of the processing. But the
Mhm.
second part of the processing, in terms of inference per second or tokens per second,
Tokens per
in this
second.
instance, the actual benefits are a function of exactly who is doing the encode and who's doing the decode over there, and there's a few more details. But we see like a substantial difference in terms of the tokens per second as we go with this. Over the next quarter or so, we'll share a little more details in terms of picking some of the models and outlining exactly what the performance will look like. So stay tuned on that front.
You spoke a little bit about software and kind of the software ecosystem. That's going to be a key element and contributor to the usability of a solution like this. Talk a little bit about how you've built out that ecosystem and how you see users taking advantage of the AI 200 and 250.
Right from the beginning, from our software architecture standpoint, our software solution actually is a complete package, but it's also modular, as in someone can cherry pick from there. That's like the first observation. We allow developers to pick any kind of a framework, any runtime. We provide all the libraries, the tools, the compilers, the debuggers, the profilers, along with it, and with an extensive support of all the flavors of Linux that is typically used in data center. What this means is that if you're a developer, let's say that you want to build some sort of an application, you want to pick some model, let's pick an open source model from Hugging Face, and you want to actually immediately go from there to the solution that we provide. We do that with a one click aspect from Hugging Face as an example. But if you're a CSP today and you are interested in, maybe I already have my stack and maybe I just want to pick like a few components from us, that's where the modularity actually plays a role. And we allow for CSPs to then pick just a few components from our complete stack and then build their final solution for themselves. And on that note, if you just take a look at the entire stack in itself, one thing that we have also done is made sure that this is, we are fully embracing open source over here, so that actually it's a way of showing the right level of flexibility in the data center, because things actually vary depending upon who your customer is.
Can you talk a little bit about how you think about the go to market for this? Historically, Qualcomm goes to market through partners, whether that's OEMs on the auto side or the handset side, or Microsoft, for example, on the desktop compute side. Where do you see it? How do you see it evolving for the data center?
In the data center, given the way that we are actually approaching this is, we on one hand, we are in a position to actually provide any level of solution that is needed. So, for example, let's say that you are an existing hyperscaler and you are in the business of building your own racks. What you really want is our SOCs and some specific solutions from us. We are actually in a position to do that. On the other hand, if you're a CSP who's interested in the complete solution, which includes the entire rack, which means all in with everything that is needed, we are in a position to do that as well. Uh, in a third option, if you have like a CSP who is in the midst of building their racks, but they actually do the procurement of different solutions from different vendors, we're in a position to that as well. So we have like several ways of addressing the market needs with our flexible solutions.
In addition to announcing the solutions that it will be available over the next couple of years, you are also announcing a bit of a roadmap. Talk a little bit about the cadence that you see for these cloud AI solutions.
We feel that given the pace at which AI technology evolves, we are treating our data center business as an annual cadence business. So expect to see like a an annual update that's coming in. That's why in this first generation of the 200 family of products, we said 200 and 250 back to back, and we expect that to continue as we move forward. So that's like a we feel it's important to be able to do that. At the same time, there is compatibility and continuity as you go from one solution to the next generation of the solution in itself, and that's a part that we are really focused on.
Great. Well, Durga, thanks so much for jumping on and sharing a bit of an update on this new product release.
All right, thanks a lot. Yeah, it was nice talking to you.